Yep.
All right. Well, good morning, TKDA, and welcome to the interview. Our first, your first. You're guinea pigs, and well, let's cross our fingers all goes well. As some of you know, we did test this with all firms prior to this interview, so hopefully this all goes well. With that, I will call the roll. When I say your name, please unmute your microphone. And then when I turn it over to Brian, or turn it over to TKDA, that's when their 25 minutes will start.
All right.
So with that, sorry, Brian. With that, I call the roll. Jennifer Barber, board support.
Here.
Erin Fogarty Miller, board support.
Here.
Sue Anderson, representing Minnesota State Arts Board.
Present.
Bill Byer, representing AIA Minnesota.
Present.
Tom Murphy, representing AGC. Tom, I did not hear you. You are on mute. No, your video. Yeah, you're on mute, Tom. Tom, are you here? Well, we're going to say he's not here for the time being, but I hopefully we'll get him back in a moment. Jan Chagaloff, representing ACEC.
Present.
Ted Tucker, public member of the board.
Present.
I turn it over to Mark, University of Minnesota.
Present. University architect, and also John Kessler from our Duluth campus is with us today.
And Tom Murphy, are you back again?
I am.
Okay, thank you. And I am Catherine Leonidas, chair and public member of the board. And I note as of this moment, we have 3 people attending as non-participants. With that, I am going to turn on my trusty, sorry. With that, I'm going to turn over to you, Brian, and begin the clock.
All right. Well, good morning. My name is Brian Morse with TKDA. I am the design team leader. I'd like to start with thanking the board and the university for this opportunity to come in front of you today. I know there's many talented architects and engineers that really wanted to be in the seats that we are in today, and we truly appreciate the opportunity and the invite. Next slide. Presenting today is going to be Luke Zupan. Actually, presenting today will be 3 of the key design leads on this project, starting with Luke Zupan as our lead mechanical engineer. Luke was baptized by fire, if you will, with respect to UMD, as Luke and I worked through the 10-story student residence hall concurrent with the UMD Dining Center. Luke hits the ground running with respect to UMD, and much like myself, lives within 5-minute drive of campus. Joining us also is Beth Tomlinson as our sustainability and B3 specialist. Beth's passion for the sustainability realm is unmatched by anyone, and she's going to be a key role in us achieving the SB 2030 objectives. Also with me today in our Duluth office here, barely 8 minutes from campus, is Wes Stobbs. Wes is going to be our architectural designer and my project architect, which means he'll be coordinating the day-to-day design team efforts of all of the people you see on the screen here and others. Next slide. I'd like to clarify a little bit just our electrical team. We're starting out with Brian Mickelson, who goes by the name Bud. Bud will be responsible for the lighting design. Ryan Lindahl with Hallberg was the engineer of record in the 2014 electrical service upgrades that occurred within A.B. Anderson Hall when it split out from Chena Hall. Ryan knows the electrical power side of this project better than almost anyone, and he will be responsible for the power side of our project. Also rounding out the team is Beth Shaler as our low voltage and security specialist. If I was to summarize in one succinct sentence what we see as the real design goals of this project, I would say it's to create a safer, healthier, more efficient, and more effective learning environment at A.B. Anderson. We break that into three general categories of safety and comfort, the B3 and sustainability, and we're giving equal billing to the concept of discovering and investigating the learning and connection opportunities that A.B. Anderson has. Luke is going to start out talking about the safety and comfort aspect of the project.
Thank you, Brian, and good morning, everyone. I just have a few minutes to talk, so I'll get right into it. I'm very excited about this project as the mechanical engineer. It's apparent through the RFP, the pre-design, and additional building review. Here you can see a snippet of the 1968 plans for the mechanical space in the art room. It's very apparent that these mechanical systems are beyond their useful life. And it's resulted in poor system control and poor efficiency, which the occupants have been experiencing. It's paramount in this project that in the remodel, we bring a contemporary mechanical system to each unique space, whether that be the art studio, the classroom, or the offices. That being said, some of the unique project challenges to a redesign of an existing building like this one are listed here. This is not a extensive list, but just a few highlights. And then I'd like to also state that we have experience and we have tools to solve all of these. The first one being limited mechanical space for routing. A building of this era does not have the mechanical chase areas that a new building would have for ventilation and for bringing outside air to occupants. We'll work through this in close hand in hand with the architectural team that you see here today to create opportunities for providing air spaces that minimize impact on sacrificing program space, which is the intent of this building. The second item here being inspiring trust. Currently, the occupants are working in a space that their needs are not being met. So it will be our challenge and our pleasure to bring a system that will inspire trust by providing comfort, providing safety, and really taking that concern out of the faculty and the students' minds so that they can focus on what's really important. And we do that by creating an efficient and easy to control system. Moving right along, there are going to be unknown conditions with a building like this, and really with any project. And so the way that we'll address that are through early site visits, meetings with the construction manager at risk, doing destructive investigations so that we can understand these complications early in the design and present something in our final package that creates a constructible and a good design. Next slide, please. What's really important in design, in my mind, is the approach. That being said, we have a pre-design and we've all had access to that. That's a snapshot in time. Many of those elements are very relevant and good ideas for this building. That being said, there's no way we can do a complete design without the owner's input. And so that'll be step one in our process, is really understanding what are the occupants' needs, whether that be the art space or the classroom spaces. What's the experience of the UMD staff? The institutional knowledge that we've gained from previous projects and previous work will be paramount. Next, we have our CM at risk. We'll leverage that as a tool to really understand cost implications, constructability, means and methods, as well as market forces that we all are living through right now in the construction world. I want to explain very briefly a couple of these images. We have a steam to hot water heat exchanger. This is something that will definitely be part of this project. We've just worked through the design of one of these with John Sawyer on campus, and so we have that experience. It's in our back pocket. Above that, we have a VAV system. This is something that's a likely candidate for this project. It provides zone control, provides access to building automation system to create good sequencing and good efficiency. Alternatively, we have a chill beam design here, which is just one tool that we could look into to provide smaller duct chases. And we look forward to exploring these options. Next slide. The penthouse is going to be an exciting area on this project, and I think it's an opportunity for us to make some adjustments in this building infrastructure, perhaps combining these penthouses to gain access for new air handlers and potentially a new generator. When we do this, we'll be working with our structural staff to understand the implications there. And I believe through our study of the building, this is actually above vertical expansion area, so that's an advantage here. Next slide, please. I just have a couple of minutes. I wanted to point out this is really the extent of the fire protection in Anderson Hall. And obviously, at the end of our project, we'll use our specialist, Brian Kelly, to develop an active and passive system that is extensive to the Anderson Hall. And the way that we can do this effectively is through BIM coordination, like all other elements, whether it's piping, ductwork, fire protection, that's strictly coordinated through our building model to create something that's constructible and something that's efficiently designed. Next slide, please. I'll now turn it over to Beth for B3 and sustainability. Thank you.
Thanks, Luke. Good morning, everyone. So B3 is going to be a component of this project based on funding and desire for a sustainable environment. I know the UMD campus is committed to sustainability, and this project is really going to be well aligned with the scope of the work on this facility. Based on the PreDesign submission in 2016, we actually are grandfathered into version 3.0 for B3, which is really useful and beneficial for this project. It allows us to have kind of reduced expectations in comparison to new construction projects or even major renovations occurring today for projects starting today. Of course, we can always opt into more aggressive options if the owner chooses. I put up a slide here just indicating what guidelines would be required and which would be optional for this project. You don't have to read through everything. The gist of it is the majority of the required components for B3 align well with the scope of the project in terms of mechanical and electrical upgrades and thermal comfort and ventilation and all the things that really are just rolled into the package. One beneficial note I wanted to point out, though, is that any of the site requirements, which is often a struggle for UMD projects based on infiltration requirements, those are not going to be expected of this B3 project because of its limited scope in civil and kind of site work. But we should be keeping that in mind if we do consider options that could impact triggering these options. Next slide. So this is a slide, and really it's a take from the USGBC's WELL certification, and I understand this is not a USGBC or WELL certified project, but I really do like the concepts that it presents here. And all of these items actually play well into the scope and the ideas that TKDA wants to bring to the staff, the faculty, the students, and that is just a healthy environment, whether it's the good air quality, quality water, access to light, natural lighting, encouraging fitness, which, in this facility, people use the stairway all the time. So, this is just understanding the use of the facility and encouraging health and wellness within its use. Next slide. So I had presented in our proposal a preliminary assessment of what B3's SB 2030 expectations for this facility would be. Again, being grandfathered in for our pre-design start date, we will be expected to meet 40% better than a typical building, which is pretty great for this facility. I know the windows have already been replaced, so that's a great step forward. But replacing with the mechanical and electrical upgrades, we're going to be able to pick really efficient systems and hopefully get to this target of 83 EUI, and that's the energy use intensity. And if you're not familiar with that, it's like the miles per gallon of a car. It's a metrics to compare buildings against each other over time or to other buildings. Next slide, please. So here's just an example of what we tend to put together for our projects. Energy modeling, a whole energy model is paramount for a project. You have components that you try to include within a sustainable project, and they counteract and they work with each other. So creating whole building energy modeling is incorporating all of the components, whether an iterative process to assess individual alternatives for replacements of one system or one envelope component, or the whole package together. This is the kind of output that will generate so that the owner can provide or have information to make an informed decision. And along with these types of presentations of impact of choices, we provide life cycle cost assessments. And what that includes is not just the short-term costs and the energy impact, but also it includes the long-term maintenance and long-term cost of replacement of equipment. So it really gives the owner a full understanding of the selections that we're presenting and making informed decisions. Next slide. So here's an example of a tool that has been recommended. It's the talk of the town. It's an image of bipolar ionization. Basically, it's just one tool for quality error. You can provide a lot of different options that provide flexibility within an HVAC system. I put this up here to just have a talking point on resilience. Resilience is just planning for adverse events, and whether it's a pandemic or it's high allergy counts, pollen counts or smoke. Really, resilience in TKDA means talking with the client about what risks do they anticipate or could they anticipate, and letting the engineers solve the issues. You're in good hands. I know this slide looks a little doom and gloom, but the gist is, there are issues out there, and we want to help identify them ahead of time so that we're making smart investments and that your facility is flexible for whatever may come so that you're well prepared. Next slide. And now I'm going to pass it off to Will. He's going to talk more about the architecture.
Good morning. While the pandemic will be behind us by the time that this building is constructed, during the early SD phase, it'd still be responsible of us to ask the questions like, is more online learning anticipated? Is there less demand for classroom space? Have faculty hoteling spaces versus dedicated offices been considered? University insights to these questions could equate to physical space that is freed up for other uses. I want to quickly take you through the architectural needs as outlined in the pre-design and university wishes. We'll be supporting mechanical and electrical by developing a mechanical penthouse enclosure, rated mechanical shafts for ductwork that pokes through the floor, and architectural finishes to cover up the ductwork in the end. There's also accessibility issues that we have to think about as we go through the project. And the university has stressed the idea of enhancing the building entrance. Currently, there is not a clear entry facade, although there is an entry on level 2, but that is not in the budget currently, so it is something we'll have to look at and work with them. Another thing that we've identified is that the facility currently lacks adequate restroom space. There's 2 present on the first floor, but realistically, the building should have 8 toilets per sex. Right now, the restrooms are allowed to be shared with the Humanities Building, and in the past that was okay. But as we work with university code officials and the university, it'll be something that we want to look at. And then this diagram kind of gives you an idea of the type of toilet room spaces that we'd be looking at, and we would probably need about 150 to 175% of that area. So something would ultimately have to give program-wise. But the project has a potential to provide more than that. We have the ability to strengthen student communities. And I want to take you through some of the architectural potentials that we think we can bring into the project, including bringing daylight into the core space of the building, improving circulation and flow, and improving physical connection. Next slide, please. Increasing daylight to the core by making a simple economical removals, we can get much needed natural light into that core space. Next slide, please. Taking that idea a little bit further, if the program can give up a classroom, for instance, a student queuing space or sticky space can provide soft seating, reduce traffic congestion, and improve circulation and flow for the building floor. Again, by removing a wall, this sticky space could also be an area where we could present student artwork on the wall from the fine arts program below. Next slide, please. And then improving connection. The second floor of Catherine Martin Library was closed off by book stacks, compartmentalized offices, and underutilized storage and IT spaces. In a project within the past 4 or 5 years, we were able to work with the university to remove these barriers and open up the space to allow transparency. The new student-centric program reinforces gathering and collaboration, not so dissimilar from what A.B. Anderson's queuing space could become. Next slide, please. With that, I'm going to turn it back over to Brian.
Well, I would like to just hit quickly on a couple of observations, and that is, the pre-design, as we've mentioned, really was a snapshot in time. There's the RFP scope, as we've heard, or we've all read, and there's some additional scope that was discussed during some walkthroughs. I guess the takeaway is it's going to be real important that we understand what the scope is as we leave schematic design. There's the code required issues, and there's the wish list. I would put the generator onto the latter, and I'd like to talk about that a bit if anyone wants to ask me a question later. I'm illustrating here the implication of taking a 5% escalation starting at the end of 2016, going to the midpoint of construction, and just illustrating that alone is $1 million. We can talk a little bit about how much of that truly is escalation versus how much might be able to be in another pot called contingencies. But I'm well versed in those conversations, and welcome that discussion with the university and the construction manager. Touching again on the construction manager, they're going to be a key partner in all of this. It's going to be very important, as I said, that as we leave schematic design, we also leave behind the study of all sorts of iterations. We need to not necessarily dash out of the gate, but at least start trotting out after schematic design towards the completion of the project. And construction manager is going to be a key partner in all of that with us. And for us, the design starts as we start putting together the team. And I really do think that we've designed the best team for this project. We have local professionals, very experienced in all the aspects that are needed for this project. We understand the campus. We understand the challenges that are ahead of us. And really, again, I just want to hit home the idea that this is much more than a mechanical and electrical upgrade and code deficiency repairs. This really is an opportunity, to create a safer, healthier, more efficient, and very importantly, more effective teaching and learning environment. So with that, those are our high points. I hope maybe there's a couple of nuggets of information in there that will generate a couple of questions. And, I guess I open it up to the board and the university to ask some questions.
Brian, I have a question. You talked about moving the emergency generator to the wish list. Is it now not part of the budget? Or
The short answer to that is yes, Bill. It is not part of the budget. It was not identified as a need previously, and I maintain quite strongly that it is not a need now. It may be a desire, but I think it might be coming from the general perception is that when you hit a 4-story building, at least on a new building, you start needing an emergency generator. Primarily for the purpose of running the elevators. And that relates to where are those floors relative to the level of exit discharge. This is a unique building. It's an odd building, but it has its quirks, but it's unique in that the exit discharge is at the 2nd floor. We're looking at with that balcony up there, that is the 2nd floor, and that is where most of the people exit the building. There really isn't even a physical connection to the 1st floor, short of going out of the building and coming in from Humanities, or taking the little tiny elevator. And when we put an elevator on emergency generator, it's usually because we're using it as a accessible means of egress, which really is only a requirement when we're over 3 stories from the level of exit discharge. So there might be some confusion as to a 4-story building needs a generator to run the elevator, both for the fire department and for accessible egress. But this is a really tiny little elevator. It does not accommodate a gurney, so right there it doesn't meet the requirements. And I've had success on numerous issues with the building code department and working through some initial perceptions that proved to not necessarily be a requirement. I can quote the code statement that says specifically, this building does not need emergency power. Perhaps there is a desire, but that again puts it on the wish list versus a requirement.
thank you.
So, Mark,
Um,
I'm going to turn it to you for the next question.
Okay, thanks. I've got 2. Is that okay?
Sure.
First, easy question for Beth, perhaps. I can never remember what phase of a project kicks in, B3 and SB 2030. So we are grandfathered when we're starting schematic design. Is that correct?
Yeah, I don't blame you, Mark, for getting confused on which phase kicks off B3 because it's changed over time.
Yeah, I think
And
so.
that's why it took me a little while to really nail down this specific project because of the pre-design. It is set that it is before all of the changes that occurred that start projects with schematic design.
Okay,
So
we're good there. All right, appreciate that. My second question is for Wes. Appreciated the kind of the plan run through in terms of design. I think this is a challenging design project, and you got my attention with the restroom analysis. But when I look at the plan, I don't know. I just don't see any give in such a tight kind of insular floor plan, and I'm wondering if you've given any preconceptions to how you're going to find that kind of space that you're requiring.
Well, we have given a little bit of thought to that, and previously in the center core there was unisex restrooms that were one toilet apiece, which would be an opportunity to utilize those on some floors, but right now they're storage spaces, so they'd have to be reconverted. And then, we could break up men's and women's toilet rooms on different levels. But, something like you had kind of alluded to, something would have to give. And, Whether that's, it would have to gobble up a couple of office spaces, or again, if a classroom could be given up. But somewhere in that floor plates, yes, we would have to accommodate some restrooms, and some floors may require more space than others, depending on how they want to be distributed. So,
sure. And I'd just like to add, Mark, that when we were having our initial discussions with the building officials, there's since been a change of building officials. In other words, Scott Holm is no longer at UMD. It's been identified for a long time that there is a deficiency in the toilet count in this building. But it was decided in our pre-design that the existing condition is what it is, and that with the major investment that would be required for toilet fixtures, perhaps we are grandfathered in, and we continue with the situation. Now, how this works is, as you leave that northern slot, the gray area on our plan, you walk directly into the Humanities Building. You take a right, you go to one of the toilet rooms. I don't remember if it's the women or the men. You go to the left, you go to the other. So they're very, very close to this building. This is a tiny little building, it's been allowed to be shared over the years. We have documentation that at the time it was deemed to be accessible and not the hill to die on for this project. And perhaps there's been some other discussions, much like the generator, that it really is more, it's advanced in its priority to the campus, but it's a budget item we don't have covered, and it was decided that it really wasn't a necessary deficiency, or at least a prioritized deficiency that we'd address.
Okay, thank you.
So I turn to the board for the next question.
Yes.
Okay, go ahead, Ted.
This is Ted Tucker. I am a brand new member of this board, and I listened very carefully, but there were lots of acronyms that flew by that I didn't understand. I'm sure I will in time. But the one I'd like you to expand on is the CM at risk. That seems particularly important with a very tight budget and many goals. So could you talk a little bit about how the CM at risk works, particularly in your pre-design stage?
Sure. And the CM at risk refers to the construction manager at risk, and it really is just one of the flavors of how construction management is delivered. It includes bringing, in essence, the contractor on board early, advising the team on preparing the estimates, advising the team on the market forces that are out there. Perhaps it's workloads and things like that start influencing the cost of construction, the availability of materials, and it really is the preferred delivery method that the university has moved towards over the years. It helps the design team immensely in that we avoid the time delay and the cost implication to everybody, and the perhaps the disruption of expectations that occur. So it's really relying on the contractor to advise the client and the architect on what the cost of the project are could be expected to be. It's really taken the estimating out of the hands of the design team and putting it into the contractor's realm.
Thank you. That's a good start.
With that, I will open the questions to the university.
Oh, Catherine, can I interject with a question? This is Sue Anderson, and I'm directing this to Brian. We're hearing about a lot of potential added scope, and there's building challenges. It's 1970 building. I'm wondering if you feel that the team and yourself, if you're comfortable with the schedule.
We are comfortable with the schedule, partially because a number of us on the team were intimately involved in the UMD housing and dining projects. We did a major push on those. They are shovel ready, but were put on hold because of the pandemic. So there's some capacity within the team, and specifically for me to jump on this project and focus on it. And the key I just want to mention again is going to be that robust schematic design time. You know, there's time within there to talk about alternatives, to talk about identify these wish lists versus requirements. The schedule cannot accommodate that lack of clarity, if you will, after schematic design. But in that initial push of schematic design with the right contractor on board, it doesn't concern me.
Thank you.
With that, I will turn it over to the university for the next question.
Sure. Question for Luke. You mentioned chilled beams, and I'm never quite sure about the efficiency of chilled beams, depending on the scale of the project. I know just enough to be dangerous. So, is that feasible on a project of this scale?
Yeah. Thank you, Mark. You know, I think that there's a trade-off with that system, and I would really only recommend that in the classrooms and perhaps the office spaces. The trade-offs are the great thing about chilled beams is they induce airflow. So instead of bringing your full quantity of air to the space and then back to the air handler and then back to the space, you're able to actually induce some of that ventilation by just the technology in the chilled beam. So really you're left with providing the primary air or the outside air, which greatly reduces the amount of trunk ductwork. So right. It's efficient in that respect. You do have some trade-offs with some of your heating and cooling. And so one of the trade-offs are you perhaps have more piping, small bore piping, versus a VAV system. So these are some of the things that will weigh when it comes to actually laying out the infrastructure of the mechanical systems.
Yeah, thanks. I would think that it's such a small, tight building that anything you can do to reduce your ductwork would be intriguing. But yeah, I was curious.
That's exactly why we brought that up as an option. And there are a couple other technologies we could look into. But yeah.
Okay, thank you.
Question from the board?
Yeah, I have a question. Extending the penthouse will create a drifting snow problem on an existing roof. And I just wonder what kind of extent of the problem and a cost implication if we need to reinforce the existing roof. Plus, to the same question, the building design in 1970, in a complicated roof kind of configuration, and I'm not sure if it's designed for the drifted snow at that time. Yeah. So need to be checked the whole roof structure.
Sure, and I'm an architect, and we didn't bring our structural engineer to the discussion on here, but I am informed enough to be even more than dangerous. But where I guess a couple of key takeaways are where the current penthouse is. That building was provisioned for multiple stories of addition. It was designed to be expanded. Now, you're absolutely right that at the time that this building was built, there was no requirement for considering snow drifting. So whether or not the code official is going to be requiring that is something that we'll have to discuss. But there is a certain amount of existing snow drifting that does occur on the building. As we look at this diagram here, where you see where the placeholder, just for budget purposes and pre-design scope definition, we show an expanded penthouse. We've been rethinking that internally, that maybe what we do is we make these two separate penthouses that are there now into a contiguous penthouse. That it will take a little bit of finesse on the orientation of the air handling units in order to get the vertical ducts where they really need to serve the larger spaces of the classroom. We may want to ask for an exception to the university standards to allow a little bit of rooftop ductwork. by far not preferred, but perhaps a solution. So I don't think that I think we could make the case that infilling that area of the building that is currently provisioned for vertical expansion, does have a lot of capacity, really doesn't add any more snow drifting to the existing roof than the current condition, especially if we can stay off of that other section over the classrooms. The area over the classrooms was not provisioned for vertical expansion. And we haven't done a totally thorough analysis on, how much capacity does it still have? So that is a concern, but I think it can be mitigated by thinking more of a contiguous penthouse, a single structure, which could serve the users much better. The users in this case being the facility folks. Right now they go into one penthouse, go outside, down some stairs, up into another. So if we can find a way to get the air handling units into that more of a consolidated penthouse, I think we're well along our way to a negotiable approach.
Okay, thank you.
Question from the university?
Yeah, Brian, I had a question about the electrical team, and I think we did maybe in the shortlisting as well. I'm looking at your placemat. I can't quite remember, but I believe you've kind of got a split team of TKDA and help me out here. Is Ryan with?
Ryan is with Hallberg.
Okay, exactly.
Right, and okay, go ahead, Mark.
So yeah, my question is simply a pretty small project. Maybe explain or maybe expound on that split and the efficiencies of it, if you could.
Yep, and I apologize that my attempt to do that didn't totally come across yet. But as we're putting together this team, one of the pass-fail requirements of the team is that there is a certain percentage in the targeted business group. Nobody really wants to join a team strictly because they fit into the targeted business group category. They want to be on the team because they're adding value beyond that they're qualified. I present Ryan as the most qualified person to understand the existing power side of A.B. Anderson Hall, because he was the engineer of record when the 13.8 primary service to the building and the 208 power to the building was split off from A.B. or from Chino Hall. So he did that original work. So as we expand that work into the also unfunded, undefined to date request that we add new panel boards, that we change out the panel boards, Ryan is the one that knows that system better than anybody but perhaps John Sawyer. So, we bring him on board and, wearing two hats as our targeted business group, but also as his sole responsibility will be the power and distribution. Bud's responsibility is lighting, Beth's responsibility is low voltage.
Okay, thank you.
Question from the board? Beth, I have one for you. And I don't need an entire primer on B3 3.0 versus B3 3.2, but tell me a little bit about what the difference is.
Well, with 3.2, if we had not been grandfathered in, I'll call it, then we would have been expected to comply with the complete energy efficiency as if this major renovation were a new construction project. So that in by itself would have been very challenging for this project. It would have taken a lot to completely retrofit the envelope and replacing the entire roof. It's a lot of work to get to where B3 wants for the SB 2030 component of the energy efficiency within B3. Other components include ensuring that you have renewable energy, ensuring that you're absorbing most of the rainwater that falls on the site, and perhaps reusing it. That's more stringent with the water efficiency requirements if we do move forward with restroom design. There's just a lot of implications that's more stringent in 3.2. And so getting into 3.0 for this major renovation allows us to invest the money, where it makes sense, not just to check off boxes that the state requires, but to make sure that the owner, the client, is truly getting the best bang for the buck for their investment in mechanical systems or the lighting systems, or even, material upgrades for the classrooms.
Sure.
Great.
And I'd just like to add, that we're aware that UMD embraces the sustainability concepts. It is way more than just checking the boxes with this group. So there's a potential, that perhaps some of those non-required items are really requirements just because of the users. This particular client, but from the standpoint of the enforcement of our compliance, we do have some latitude.
Yeah, like I mentioned, you can always opt into the other version requirements or recommendations. Any of those are available to us, specifically renewable energy. I know that PV is of interest to UMD. You're not going to be required to install it, so we have flexibility of what we choose and which is the key criteria for the owner.
Terrific. Question from the university.
No further questions.
More questions from the board. Well, with that, Brian, you've got about 50 seconds. Closing remarks.
Okay. I'd just like to, end with saying I think we did design the right team for this project. I think we brought together the right people, the right skill sets, the right timing, the right location. We're ready to hit the ground with John Sawyer January and bring on the construction manager and deliver that project that does meet the, improves the health, safety, and welfare of this building and makes people feel safe and comfortable being in it.
And with that, we are going to stop this interview, and thank you very much for your time today. And you can expect to hear from the executive secretary in the next couple of days.
Okay, I would just thank you, and I'm going to try to get out of the meeting. And if by chance I have a problem, kick me out.